All right, happy Friday, everybody. We are going to look at a new form of a line today, and it is called standard form. So we already know slope-intercept form, which is y equals mx plus b. M is your slope, and b is your y-intercept. Now we're looking at standard form, which is ax plus by equals c. So basically what this means is we want the x term to be first, we want the b term to be second, which is with your y, and then we want the number that doesn't have a variable to be on the other side of the equation. So the a, b, and c just represent numbers. So if you look at the first three examples, those are all in standard form. Because if we look at number 1, 4x is first, 3y is second, and then it equals a 20 that doesn't have any variables. So a would be 4, b would be 3, and c is 20. Now the directions for 1 through 3 say that we need to rewrite it into slope-intercept form, which is y equals mx plus b, which means we need y alone, and we've been practicing this already. So if we look at number 1, I need y to be alone. There's a 4x and a 3, keeping it from being alone. So I need to subtract the 4x first. And we are left with 3y equals negative 4x plus 20. Now we need to get y alone by dividing everything by 3. So the 3's cancel. We have y equals negative 4 over 3. Does that reduce at all? No. So it stays negative 4 over 3x. 20 over 3, does that reduce? No. So there's your equation in slope-intercept form. Let's try number 2. Y is not alone. We have a negative 3x and a 2, but we have to get rid of the 2 last because it's right up against the y. So to get rid of the negative 3x, we have to add 3x to both sides. So we're left with 2y equals, we write the x's first, so 3x, and then plus 19. Now we're going to divide everything by 2 to get y alone. So we have y equals, does 3 over 2 reduce? No. Does 19 over 2 reduce? Nope. So there's our final answer in slope-intercept form. One more like this, number 3. Again, we need y to be by itself. There's a 5x, and I also see a 4 in front of the y, so we're going to have to get rid of both of those things, but we can't get rid of the 4 yet. That has to be last. So to get rid of the 5x, we have to subtract 5x to both sides. Now look what's left. This is a negative 4y. So we have a negative 4y equals, put the x's first, so negative 5x plus 18. Now we're going to divide everything by negative 4. Negative 4's cancel. So does negative 5 over negative 4 reduce? It does, because a negative over a negative is a positive. And then does 18 over negative 4 reduce? It does. It becomes 9 over negative 2. So there's those 3 examples where it was in standard form and we changed it to be in slope-intercept form, which is what we've practiced already. Now we're going to look at an example that takes lines that are in slope-intercept form and we're going to write them into standard form. So this is a little new for us. So standard form, we have to get all the x's first and then the y's, and then we want all the plain old numbers by themselves on the right. The other thing about standard form is that we can't have any fractions. So there will be a couple examples that we're going to have to get rid of the fractions that we see. But before we worry about that, let's focus on the first example. So right now, y is alone. This is in y equals mx plus b form. But we want to change it so that the number is alone. So I actually want 2 to be alone. So to get 2 alone, I have to subtract 5x from both sides. And remember, in standard form, we want the x's first. So I'm going to write minus 5x first. Then there's a positive y equals a positive 2 on the other side. And then we're done. So in this form, the x's are first, then the y, and it equals the number. So the number's all by itself. Let's try number 2. Right now, y is alone, but what we want to be alone is this negative 2. We want the number to be by itself, which means we have to get rid of the negative 3x. So to undo a negative 3x, we have to add 3x to both sides. And again, we want the x's to be written first. So we have 3x plus y equals negative 2. And then we're done. Try number 3. Right now, y is alone, but we want the number to be alone. We want this positive 3 to be by itself. So in order to do that, we need to get rid of that x. So we are going to subtract x from both sides. We want the x's written first in standard form. So we have a negative x, we have a positive y, and that equals the positive 3 on the right. Great, so when we look at the next 3 examples, they involve fractions. And in standard form, we can't have any fractions. So I'm going to show you how to clear out the fraction. So with number 4, ask yourself what number is in the denominator. So I see the 1/2, and there is a 2 in the denominator. So we are going to put parentheses around this entire equation, and we're going to multiply the entire equation by 2, because that was the number in the denominator. Now what comes next is the distributive property. So this 2 has to distribute to every single term. It's going to distribute to the y, so 2 times y is 2y. It's going to distribute to the 1/2, so 2 times 1/2 is just 1, so 1x. 2 times 3 is 6. So by doing this, we've cleared out the fraction, and the fraction is gone. But we still want this to be in standard form, so we need the number to be by itself, which means this positive 6 needs to be alone. So I'm going to have to subtract this x from both sides to get that 6 by itself. So we want the x's to be written first, so we have negative x plus 2y equals 6. All right, let's try number 5. There's a fraction. We cannot have fractions. So look at the denominator. The denominator is a 3, so think to yourself, what would we multiply this entire equation by? We're going to multiply the entire thing by 3, because that was the denominator that we want to get rid of. So this becomes distribution property. So this 3 is going to distribute to every single term. So 3 times y is 3y. 3 times negative 2 over 3 is negative 2x. Those of you that remembered your calculators, please feel free to put your fractions in your calculators. Just make sure you use parentheses. And then the last term, 3 times 5, is 15. Now again, the goal is for this positive 15 to be by itself. So to do that, we have to get rid of the negative 2x. So I'm going to add 2x to both sides. We want the x's written first. So we have 2x plus 3y equals the 15. Good. Trying number 6. there's a fraction. We have to get rid of the fractions. So in the denominator is a 7. So think about what we're going to multiply this entire equation by. So I put the entire equation in parentheses. We're going to multiply by 7. So now we need to distribute to every single term. 7 times y is 7y. 7 times 6 over 7 is going to be 6x. And then 7 times 3 is 21, so that becomes a minus 21. Now we need this minus 21 to be by itself, so we have to get rid of the 6x. So we're going to subtract 6x from both sides. We want to write the x's first. So we have a negative 6x plus 7y equals that negative 21. All right, so those last 3 examples had fractions. Now I want you to flip to the back, and the next 3 problems have more than one fraction in them. So let's see. Starting with number 7, you have 2 fractions. One of them has a denominator of 4, the other one has a denominator of 2. So your goal is to find the least common multiple. So the least common multiple between 4 and 2 is 4. Think of it like finding common denominator, but the smaller common denominator that you can find, the easier it's going to be. So we need to find a number that 4 goes into nicely and 2 goes into nicely. So 4 would be our best bet. It's the smallest number that 4 and 2 both go into nicely. So that's how we choose what number to multiply everything by. So now this is going to be just like what we were doing on the front. I put parentheses around the whole equation, and we are going to distribute to every single term. So 4 times y is 4y. Negative 3/4 times 4 is negative 3, so that's a negative 3x. 5 over 2 times 4 is going to be 10. And again, if you need to use your calculators, just remember to put parentheses in your calculator. Then we're still trying to put these in standard form, so this 10 needs to be by itself. So I'm going to add 3x to both sides. We need to write the x's first. So 3x plus 4y equals 10. Let's try number 8. We have 2 fractions, so we need to find the least common multiple. Our denominators are 8 and 4. So we need to find a number that 8 and 4 goes into nicely. That number is 8. 8 is the smallest number that 8 and 4 both go into nicely. 8 times 1 is 8, 4 times 2 is 8. So 8 is going to be the special number that we're going to multiply through the entire equation. So that means now we need to distribute. So 8 times y is 8y. 8 times 1 over 8 is 1, so that's 1x. And 8 times negative 3/4 is negative 6, so that's a minus 6. Now in standard form, we need the number by itself, so we need the negative 6 alone. So to do that, we're going to subtract x from both sides. We want to write the x's first, so we have a negative x plus 8y equals negative 6. All right, I'm going to let you do number 9 in a minute. That's more like the ones on the front. It's similar to 4, 5, and 6 on the front. So I am going to skip to number 10. That way we can do one more together with the 2 fractions. So number 10, the denominators are a 6 and a 2. So we need to find the least common multiple. We need a number that 6 and 2 both go into nicely. Well, 6 times 1 is 6, and 2 times 3 is 6. So 6 is the smallest number that 6 and 2 both go into nicely. So 6 is our magic number. So now we distribute. 6 times y is 6y. 6 times negative 5 over 6 will be negative 1. So that's negative 1x. Oh, I'm sorry. Getting ahead of myself. Negative 5x. There we go. And then 6 times 3 over 2 is going to be 9. Now we want to get the 9 by itself. So we are going to add 5x to both sides. We want to write the x's first, so we have 5x plus 6y equals 9. All right, I would like you to take a couple minutes to try number 9, number 11, and number 12. Once you finish those 3 problems, the substitute will hand out your homework. So make sure you get those 3 problems done and that you can show the substitute that you tried those 3 problems before you get the homework. All right, guys, have a great weekend. Hope to see you at Minithon.